I've redone this video a couple times in the last 3 weeks, and I wanted to get this into the beginning of the video, but the fuel injector logic on our cars, passenger side, number 1, 2, 3, and 4 on our intake valves, and the way the ignition works is the rotation is 1, 3, 4, and 2. So the fuel injectors are normally tied number 1 and number 2 together, and number 3 and number 4. That's the way our engine controller, the SMEC, controls them. The way I'm going to do it with the Microsquirt is different, because I want to give a gap between each injector that fires, and the injectors are fired in pairs. I have 2 outputs on the Microsquirt for injectors, but I've got 4 injectors, so that means 2 of them have to be fired at the same time. So what you would do is fire number 1 first as the valve is opening, and then fire, that's on batch 1, and at the same time on batch 1 you're going to fire number 4, which is closed, because the can hasn't come around yet. And then on injector 2, the next can that's going to come around is 3, because 2 is still up in the air. So you're going to fire 2 and 3 injectors at the same time on the second batch of the injectors. And number 3 is going to open. Number 2 is still closed. Then batch 1 is going to fire number 1 and number 4 as number 4 is opening, and number 1 is staying closed. And then number 2 is going to be next, so we're going to fire 2 and 3 together. So what you've done is you've spaced out the pulses on the injectors to be even. In other words, 1 and 4 fire, only one of them will open, and the other one will have to go halfway around rotation before it fires. But then both of those injectors will pulse at the same time, open. So you're really spreading out your duty cycle so that one valve is open, one valve is closed when each pair of injectors is being fired. So 1 and 4 fire together, 2 and 3 fire together, and it just keeps spacing out regardless of whether a valve is open or closed. There's always going to be one open, one closed. So that's really if you're confused by batch logic, that's how it works, is that you're always going to have one valve open when it's firing and one valve closed, regardless of where it is on the engine. But the factory does it, for some reason, they fire 1 and 2 together and 3 and 4 together. But it doesn't make sense if you figure out the pulses on the injectors. You're actually making them fire faster than they need to fire. So by spreading them out, it's going to work a lot better, hopefully. I hope that makes a little bit of sense. It's tougher to explain than it really is. It's just getting your head around it. It took me a little while to figure out what the negatives and the positives of batch mode were. But the factory used batch mode for years and it worked fine. If you went to the Microsquirts, you can go to the sequential, where each injector is completely independent of all the others, so you can fire them anytime you want. But that's the only difference really in the process. The Microsquirt project is going to require redoing the fuel injector wiring. Reason being is I wanted to extend it so that this male plug will be far enough out of the intake manifold that I could easily plug another connector onto it. So I'll have the one coming from the SMEC, and then when I remove that, I can put the one in coming from the Microsquirt, and that way I can switch back and forth between them. They're going to be in batch fire mode, which means 2 injectors will fire at on the same signal, and then the other two injectors will fire on a different signal. My intent, though, I had to make the wires longer. I figured while I was doing it, I cut all the original wires out of it and soldered in new wires. These are automotive wires, 14 gauge, a little heavier than what was stock, but they aren't brittle. The original wires were all brittle and they were cracking. The insulation was cracking. And then you've got two ground wires that comes out on pins 4 and 6, I believe it is. The one thing that is different is the Microsquirt cannot fire low ohm injectors. My injectors are the Mopar plus 40s. They get 53 pounds per hour, and the resistance on them is 2.5 ohms each. So if you go across these two pins, you get 2.5 ohms. Now the Microsquirt, Megasquirts, I think the Megasquirt might do more, but the Microsquirts want to have it around 10 ohms on the injectors. So if you don't have that, you have to add a resistor that'll bring it up to 10 ohms. Here's the mock-up, well, the finished product, I should say. This is my male connector. Here's the two stock connectors going to the SMEC. And then I'll have another one going back to the Microsquirt. So that I'll have the ability to just quick plug whatever system I want to run. I can't remember if I covered this or not, but the way our cars worked were the air for the heater and AC comes in through this hole, and then it migrates over and goes into the heater box behind here. I didn't like that idea because you've got all that heat coming out of the hood, and that was coming in this area and getting sucked back into the car, and this is a hot area. So I had the bright idea that if I could move the window washer over to the center of the car, that would open up this space, and then I could cut this out with a Dremel tool and let my cool air come in on the passenger side. And so my thought was it would come in through the fender by the door and through the side of the fender here, and also through the top. And then it would come in and flow in, and that would give me cool air. I thought it was a great idea, but unfortunately it didn't seem to make the air any cooler. So can't say it was worth the effort, but I'm there now, so that's where I'm at. The reason I bring this up is I'm mounting the wiring from the Microsquirt to the fuel injectors. And what I've read is that you need a 25 watt resistor in line with each injector wire. Well, not wire, but pair of wires. So you can't, even though they're running in batch fire mode, you have to run separate resistors. So what I did was I ordered 4 25 watt resistors, got them off eBay. Paid about 12 bucks a pair, including shipping, so pretty reasonable. And then you need to mount them to a heat sink. In some areas they're going to get cooled. So obviously mounting them in behind the engine is not a good idea because you got all that hot air coming off the turbo and the exhaust. So my thought was I could mount them up here under this plate, and then I could run my harness through the firewall and over to the injectors through the back of the intake manifold. So that's the plan at this point. I'm going to run a complete separate harness that will run to the Microsquirt. So if I want to go to the SMEC, I'm plugged into this harness. If I want to go to the Microsquirt, I'll take this harness off and run a new harness. I'll have a new harness in place that'll just go in through the back of the intake manifold. One of the handy things that I've used over the years for cutting holes, number one is the hole saw bit, where you can punch in different holes I'm sure everybody knows about these. And there's also another option you can use. And that's a hole punch. And the way it works is you've got a cutter, a bolt, and an outer mandrel. And by threading them together on both sides of the metal, you can actually attract it together, draw it together, and knock out a hole. If you find yourself in a situation where you can't do the whole hole with a unibit, you can come in with one of these knockout punches. If you got a 12-point socket you can get on there, you can draw it up and punch it through, or you can just use a wrench. Now that I have my microphone back on, I thought I would go over my connections. I've got the main wires coming from the Microsquirt, and this is for injector bank 1 and 2. And I've also got power that's going to go to all the fuel injectors. That's 12 volts ignition power. That's coming from the console fuels panel. This connector goes to the bank of resistors, 25 watt resistors, and then the harness comes out of there and goes over to these 3 weather tight connectors, one for bank 1, bank 2, and my power. And I've got them reversed so that it's female male and this one's male female, so you can't get them screwed up as to which one you're dealing with. And then a single for the power. Yeah, I'm going to put a loom on here and cover that up. And then the loom for the injectors themselves. So when it comes time to start running Microsquirt, I'll just yank all these connectors off my injectors that are going to the SMEC at the moment. As I stated before, I've got my grounds that are going to the SMEC, and that's through the connector that's down here that also goes to the injectors. So I'll disconnect this connector, remove the injector harness, and then I'll plug in the connector to this one that has the 2 ground pins, and that'll give my SMEC grounds at this point, like the factory uses. I don't know why they need to be here by the injectors, but that's where they're going to stay. So then this harness will go away. I could probably actually leave that buried in there, but I'll take it out. So running wise, the fuel injectors will run off the Microsquirt. Now the temperature sensor for the intake manifold going to the SMEC, that's here. And when I go to Microsquirt, I'll plug into this one on the back. So I'll do away with the need for this one. So I'm trying to make this as parallel of a system as I can. And that way I'm not locked in that if I can't run one, I'm stuck. I can't run anything. So my plans again are initially to get the fuel running off the Microsquirt, and then the ignition running off the Microsquirt. But to start with, the SMEC will control everything, just like it does normally. That'll do it for this week's video.